My name's Kevin Robertson. I'm the fire ecologist and the Fire Ecology Program Director at Tall Timbers Research Station and Land Conservancy. Fire ecology is the science of how often fire happens, when it happens, how these things influence the plant species in a plant community. The reason we light fire specifically is to top kill or to kill back the hardwood or the woody broadleaf species in the community, so that we can release competition for the herbaceous species, the grasses and other herbs in the understory. A policy that regulates prescribed burning is mostly concerned about air quality, and we want to get those numbers right because we want to give the politicians and the policymakers the right information to make good decisions about that. And so knowing how to burn, when to burn, how often to burn, what are the effects of the burns are all important for maintaining these very species-rich plant communities and all the animals that they support. Stating why we burn is important because that allows us to monitor the results of the burn and decide whether or not it did what it was supposed to. And sometimes that may lead to us modifying our prescription so that we burn under a little bit different conditions next time. The main areas of my research could be broken down into plant ecology as one. We do a lot of research on fire behavior and fire effects. Another part of our research has to do with air quality. We also do studies on how fires are affecting the soil, and maybe even most importantly, how much carbon's accumulated in the soil and how burning at different fire regimes or not burning is going to influence carbon sequestration, which is on everybody's mind these days because of concerns about global warming. Well, this is one of our research plots right here that hasn't been burned in 3 years. And you can tell that it's a little bit different than just right across the road here where it was burned earlier this year. You can see a lot of soil exposed. Most of these, well, all of these plants have come back, mostly resprouting from the roots since we burned somewhere around March this past year. This is our 1-year fire plot that we burn every year. And as you can see, even just within a week of burning, the vegetation's already resprouting from its roots again, which just shows how well adapted this community is to fire. This is one of our research plots that was burned at the same time as the other one that we looked at a few minutes ago. The difference is this one had gone 3 years without burning before we burned it, and the other one had only gone 1 year without burning. So you can see some of the difference that a little bit of fuel accumulation, or in this case about 3 times the amount of fuel accumulation, makes. There was more heat released, the residence time is longer, meaning the fire was burning longer at one place to burn up all that fuel. You can see that what we call crown scorch is a lot higher. It's scorched the needles up several meters. These are the kinds of things we want to measure because this might be important to a forester who wants to know what's going to be the effect on pine growth, pine mortality. We map all these trees and then recensus them after we burn them so that we can look at those longleaf pine dynamics over time. Okay, we're in the inside of this research plot that's been fire excluded for over 50 years, and you can see the sharp contrast between this and the open pine forest. A lot of these hardwoods that are in here used to be those resprouts that would get killed by fire every time we burned, but without the fire, they're allowed to grow up and get big. And one of the main differences you see is we don't have that species richness of herbaceous plants on the ground. It's pretty much just leaf litter on the ground and just a few plants. So you can see that the shading of these hardwoods being released from fire causes all those other species of plants to pretty much disappear. The more often you burn, the less smoke is produced by each individual burn. So you can think of prescribed burning as kind of an insurance policy where you pay a little bit over the long term to avoid a big catastrophe. There might be a little bit of smoke with each burn, and we might have that smoke pretty often if we burn every 2 or 3 years, but that's a lot better than trying to put out fires and then having a big wildfire where you just smoke in a whole city and have people going to the hospital because of asthma and other air quality problems.